demonstration of our CSE 400 project. Our project is CodeMentor, and we have used a modular layered architecture for our project. In our architecture, we have 4 different sections: backend, frontend, chatbot, and code editor. Chatbot and code editor are 2 separate modules running. For backend, we have used Spring Boot. For frontend, we have used React. For chatbot backend, we have used Python, and for code editor, we have used Node.js. Our backend is running on an layered architecture. If we expand the backend, we will see the source files of the backend, and there are the components of a layered architecture all are present here, like firstly DTO, then repository, then service, then controller, and all other things, right? So we can go all in all the section to see what is there. In details, we have all the separate components for each execution service. Then we have the controllers of it. Then we have the repository of each section, and we have the service of each section. Now coming to the security section of our frontend. In the security section, we have implemented JWT token authentication for our service, so that each user have their own profile and one's profile cannot be breached by another. And we have also configured our security endpoints so that the restricted endpoints cannot be used by any random users. We have also developed tests for backend. In backend, we have written tests for each section. Like for controller, we have different test cases for domain section, for secure service section, and for repository section. And that's all for the backend section we have developed.
Used React for our front-end framework. We have created pages for both our admin and user side. These are the user side pages: study materials, problem selection, live coding, companies, article, company questions. And these are our admin side pages, like admin article, admin auth, admin companies, admin dashboard, admin questions, and admin users. We are using Axios to call the backend APIs from our frontend, and the response is rendered on the frontend. We have also written extensive test cases for our pages. This article, we have tested article, auth, and dashboard, not found, problem selection, and study materials, these pages. Then coming to the code editor section, we are using Judge 0 as our code execution service to execute the code using users code and input. We take the input, code input from our user, and the input section that user provides to run any code, and send it to the Judge 0 API. The result returned by the Judge 0 API is rendered on the front end. Then for our chatbot, we have used Grok API. Our chatbot AI code solution and the AI debugger section uses this chatbot functionality. We take our user input and send it to the Grok API for output, and the output is rendered on the front end for the chatbot. And for AI code solution and AI debugger, the context is taken from the front end page, like the question, the expected output, etc., and all this information are sent to the AI model, and the output written is rendered on the front end.
Along with our unit testing in both backend and frontend, we also did some end-to-end testing for some features. If we go to the end-to-end testing folder, we can see that we have a written test for these features, which is like article reading. An unauthenticated user can read the article, and then an authenticated user can read the article, and user can first register and then create a new article, and then we have tested that a registered user can search the company based question bank and land onto a specific question in the code editor. And with this we have also some simple navigation end-to-end testing that uses our real database instead of the mock database. Okay, so after the end-to-end testing, we also employed like the CI/CD deployment for the whole project. Like we have created 4 modules, so backend, frontend, chatbot, and code editor, and each module have their own Docker file here. The backend Docker file is like this, and the chatbot Docker file have its own dependencies that it requires, and then the code editor Docker file has like node.js dependent dependencies, and then the front-end Docker file also have their own dependencies here. And we have also used nginx in our front end that can effortlessly reach the backend during our deployment. Then we have written a Docker compose YAML that composes all these 4 Docker files and created a compose Docker app, Dockerized app. And we have deployed and created a CI/CD flow with our deploy.yml GitHub workflow that uses GitHub Actions, and it works whenever we give a push or commit in the main branch of our repository. And in that main branch push, we get to see that it run tests on both sides, backend and frontend, and then it get all the images from the backend frontend Docker files, and then it pushes those images in the Docker hub, and then it SSH into the Azure VM we deployed. And in that VM, these Docker images are first downloaded, and then these Docker images are run. So we can see that if we go to our GitHub repository, here in the actions, we can see all the workflows we have run. Like the latest workflows, we can see that it ran some tests, different tests, and it also completed the deployment step with all these steps. So this is our total backend and code base. That's all from us.